Hello everyone, welcome back. Now let us start problem number 12.35, which is on page number 518 of Griffiths electrodynamics chapter number 12. So in this question he is saying in the past most experiments in particle physics involved stationary targets. One particle was accelerated to a high energy and collided with target particle at rest. The figure is given like here. All right. Now he's saying that far higher relative energies are obtainable if you accelerate both particles to a energy E and then fire them at each other. Like in figure B, that they are accelerated and then them fired towards each other. Then he's saying classically the energy E bar of one particle relative to another is just 4E. Not much of a gain, only a factor of 4. But relativistically, the gain can be enormous. Assuming the two particles have same mass, m, show that E, alright. He's saying that energy E bar is equal to, we need to show this is energy E bar. And where E is energy of one particle related to another minus mc square. This is one particle related to another. So as we know that if we are talking about this frame, that two particles are coming, they are accelerated and then coming towards each other. Then he's saying energy of one particle. It means we need to take one particle at rest and then make the calculation according to the other particle. So let us do that. But the main problem is that we do not have the transformation for one frame to another frame, that from one particle to in related to other particle in momentum and energy. We know in coordinate and time, the Lorentz transformation, we very well know that gamma times this and t prime, or you can say bar. But we don't know about what about t and e. So we need to calculate these two first of all and then proceed the question. So this is the trick in this question, that you need to first of all consider the transformation of prime frame of momentum, or you can say energy, to the unprimed frame. So let us calculate. As you know that momentum is equal to gamma times mc comma mv. We very well know that for one particle which is at with respect to what we are calculating. Now, if we are going to consider the time part only, then we can say that you can write like this. Oh, and if you are considering the space part, then you can write it like this: gamma times mv. Okay. Now, where v? What is v? I need haven't spoken about v. V is the velocity of one particle related to another particle. So by using Einstein's velocity addition rule, we have used the velocity addition rule. You can write it as u plus v dash plus 1 upon u v dash upon c square, where v dash is the velocity in prime frame and this is in the unprimed frame. All right, and this is the relative. Now, just putting the values and then calculating. Let us first write the gamma in terms of v, because gamma also contains v and we need to substitute v also here. So substituting v, 1 plus uv dash upon c square upon under root 1 minus u plus v dash upon, u plus v dash upon 1 plus uv dash upon c square whole square. So this is the value of momentum in, you can say that in, this is not in the prime frame, sorry. This is the prime frame, is this, the velocity is, this is the relative frame, all right, with which we are calculating. Now on further calculation, you will find that you will get your momentum like this, somewhat mv dash plus u e by c square, all right, where e is the total energy. This is the prime frame velocity. All right. I'll attach a link for a website where you can understand it a bit more and in a clear way. Please check in the description. You will be having a link of a website. Now we have got the relation of prime frame and unprimed frame in the momentum. Similarly, the link I will be attaching, it must have been it must be containing the relation for E prime frame. If you are talking about energy transformation from prime to unprime and momentum transformation from prime to unprime, you can see there. Now continuing, as we have got the transformation, Now simply applying the transformation. So for transformation, let me suppose that it is p prime, the prime frame, gamma times p, for this zero, the spatial time part, and beta times, what is beta? Beta is b by c, or you can say in this case u by c. So beta times p prime. Why p prime? Because in this, not p prime, sorry, p1, because this is the time part. All right, sorry, space part. Now putting the values, for this, it is uh, p in prime frame, it is e prime by c, gamma times p in p, p0 is written as e by c minus beta times p1. And what is p1? In From upside we can write at gamma times mv. All right, p1 is gamma times mv. So I'll be writing gamma m into v, and we very well know that what is, sorry, what is v here? V in this case is beta times v is equal to beta times c. So net we'll be getting from this equation, what we'll be getting is e dash is equal to gamma into e. I have cancelled c from both sides. Gamma m beta square c square. This will be the equation. I hope you understood. But uh, now considering the other, but the uh, as as we know that the other particle with related to what we are taking is moving in the opposite direction. We have kept it at the rest, and this is moving. So the velocity is negative here. So what we need to consider, velocity is negative, so we'll be applying a negative sign. Why? Because with relative to what we are calculating is the velocity is the negative for that part, minus v for that particle. All right. Now calculating ahead, we get gamma into E plus gamma square, beta square, C square, and a M. All right. It is equal to E bar, E prime. Now calculating further, as we know that what is gamma? From total energy, we know that gamma is equal to mc square. Oh, E is equal to gamma mc square. So gamma becomes E upon mc square. Now putting the value, we get E square by mc square plus again putting the value of gamma. What we get? E square by m square c raised to power 4 and beta square. We need to calculate beta square from here. We know that gamma square is equal to 1 upon 1 minus beta square. Just shifting the terms, we get 1 minus beta square is equal to 1 upon gamma square, and beta square comes out to be 1 minus 1 upon gamma square. Putting the value here for beta square, 1 minus 1 upon gamma square into c square. All right. E bar, let me change the pen, it will be more clear. E prime is equal to E square upon mc square plus m, uh, 1m cancels. Let me just calculate a bit more, then we'll be cancelling. M E square m square c4, and what is 1 minus m, this term 1 minus m square c raised to power 4 upon E square into c square. Further calculation in this manner, we get E square by mc square. If you see carefully, see that this is cancelled by this is cancelled by this, and we get plus from here for this one E square by mc square minus this got cancelled, this got cancelled, this got cancelled, this, and we get mc square only, this m and this c square only for this negative part. So we get E prime is equal to 2E square upon, sorry, 2E square mc square minus mc square. So this is the value. I hope this is the formula what we need to calculate. Let me just check. Yes, 2E square mc square minus mc square. So this is the energy in prime, transformation of energy in prime frame and unprime frame. The main concept here is, I hope you get it. First of all, write the momentum in prime and unprime frame. Just put the values for P1, P0, P prime. It is negative, remember it. And just simple manipulation of terms, and you will get your answer. In other part, what he's saying that suppose you use mc square is equal to 1 giga electron, E is equal to 30. what we need to calculate, we need to, what E bar do you get? So just put the value of E as I guess it is 30 gigahertz and MC square as, so 30 gigahertz and MC square as 1 gigahertz. So putting here, you will get your answer easily. I hope you understood. I'll be attaching the link of the website to get the, to understand the concept a bit more. And if you have any doubts, then please let me know in the comment section. I'll be helping you. And please try to do your this problem after going to the through the website by your own, by pausing the video. And please do this part also. It will be help you in going through these limits. What is giga, electron volt, and other things. So that's all for this video. See you in next video. Bye bye. Thank you.